All right. Thank you, everyone, for coming out to our session here, Making It Big Without Breaking the Bank. I'll be joined by Greg Scallon, who's Chief Architect at Flipboard, as well as Jim from Yelp, where he's the engineering manager for their data mining and big data efforts. So, making it big without breaking the bank. When you're in a startup, everything is scarce. And so what we hope to talk about over the course of the coming 50 minutes is to provide some perspective, both at a high level around observations of how to effectively spend your time and money towards building something great, as well as more tactical observations and best practices from Jim and Greg on how to make the most of your AWS spend and to really scale the spend effectively as your business itself is scaling. So that is what we'll be covering over the course of the next 50 minutes. And just to give you a little bit more of a roadmap of how we plan to go through it, I'll start off and offer a perspective, one person's perspective from the venture industry around observations of and trends around how we've seen venture-backed startups spend money and time in ways that are really feel like effective best practices and ways that may fall short of that bar. And then talk a little bit about optimizing your costs as you grow, and in particular some of the trade-offs between agility and time to market versus cost optimizations. When does it start to make sense to really start to tune the levers around cost versus willing to accommodate a little bit more lower utilization in order to get to market effectively and get your product out there? And then lastly, we're going to dig in a little bit more with big data use cases, and specifically on Amazon's managed MapReduce product, Elastic MapReduce, around how to use RIs and spot instances effectively to drive down costs. So that is the roadmap, and I'll be starting us off with a venture perspective. And to do that, I'll give a little bit more of an introduction for my firm and for myself. So I'm with Kleiner Perkins, Caulfield & Byers. We're a venture capital firm based out of Silicon Valley. We just hit our 40th anniversary this past year. So one of the early venture firms on Sand Hill Road. And over the course of that time frame, made on the order of 600 investments, 190 IPOs, and hundreds of M&A events, companies including Google, Amazon, and more recently Twitter, Square, Spotify, and Flipboard. So that is Kleiner Perkins. I joined just this past November as one of our investment partners there, and prior to that was at Amazon Web Services, actually, as running the product management team for databases. So have a little bit of a unique perspective there, both from having worn the AWS hats as well as now being in the venture industry. And I think what has been interesting for me and a privilege over the past year is you get to meet and work with many high-quality startups. And part of that enables building some observations and trends around how they're spending money and time against their goals and on infrastructure. And you see some practices that seem to make a lot of sense, at least to me as a focus group of one, and some that maybe make less sense. And so I'm going to look at that through lenses of stage. So starting out your company, building your initial application, seeing if you have something that people want, then let's say you do, how to grow experiences of companies that are growing, and then startups that have reached scale. And obviously that's a loose term there, as well as talking about some of the questions that you might expect from your board or your advisors, or that you might want to ask yourself as you're going through that growth phase around whether you're spending your time and money in effective ways. So you're all here at this conference, so I don't want to preach to the converted. I think many of you have come to the conclusion that it makes a lot of sense to start your application or your business on Amazon Web Services. But I did want to re-hit the high points on that, particularly from the perspective of being a startup. In a startup, nothing is more critical than focus and really focusing in on your application, what makes you unique, what your users really care about, you're going up against competition and a large number of challenges, so you really need to hone in on what can you be the best in the world at and focus all of your resources at that. And AWS enables that to a great degree. Big part of that is around the speed and the flexibility. So in 2012, relative to doing a venture-backed startup maybe even a decade ago, there's a lot less technical risk. When you know what you want to build, it's a lot easier to build that. A lot more tools have advanced. The engineering know-how is advanced. But the market risk is often the biggest element that you want to take out. You can build it, but then are people going to want what you built? Do the dogs eat the dog food? And so a lot of that is getting it out there quickly, listening to customers, iterating, responding to the feedback you're getting to get to something that customers ultimately want and are excited about. And what's so important about AWS and the cloud there is that it enables you to rapidly iterate and get out ideas, and then to have the flexibility to scale those applications if they're a hit. And it makes it a lot easier things that would have been a huge headache or wouldn't have been possible a decade ago, particularly around, say, being fault tolerant, being located in multiple geographies where your users are, handling different failure events. So all that stuff gotten a lot easier with AWS, and it makes a lot of sense to start your application there. But in the description for this event, we talk about spending your time, spending your money effectively. And the interesting thing is, if you look at a venture-backed startup, the majority of the capital isn't going into the infrastructure. The majority of capital is going into the salaries of the people that work there. And the majority of those salaries are going to the engineers that are building the product. And so really the precious resource, the scarce resource, is developer time. And that's kind of a truism that everyone can say, but I think the real thing that we observe is, are people being ruthlessly objective around what are the best uses of developer time, and making a long-term optimization on that. So there's the initial cut, which is, hey, should I be building all my own infrastructure, or should I be running on AWS and taking advantage of them doing all that undifferentiated heavy lifting? That's gotten a little bit more obvious in 2012, that it's nice to offload that to Amazon, where that's their core competency, and you focus on your application development. But some of the stuff gets a little bit less obvious from there. It starts to get into tools and technology choices beyond just the platform. So one of the ones I think is interesting is looking at some of the managed higher-level services in AWS, for instance. Most people are running on EC2, on S3, and comparatively to that, fewer are using some of the higher-level services. Let's say a DynamoDB or an RDS, and a lot of people are using those services, but it's still early days. And I would say that it's interesting in talking to developers and startups about that. You often hear, well, I'm afraid of lock-in. I'm afraid of lock-in. I'd rather manage it myself with open source databases on EC2. And this is just picking one particular example. And I think that's an area where it's worth thinking through, because one, I think the lock-in is lower than people is a lot lower than people expect. It's pretty easy to export your data out of something like DynamoDB. But the other thing I'd say is, just remember there's no free lunch when it comes to developer time. So yes, you might, what cost do you want to pay to avoid all lock-in? And cost in terms of time. Do you want to learn how to deploy and configure a large Cassandra cluster? Do you want to learn how to rebalance the data across multiple nodes when you're experiencing a traffic spike and you need to distribute that I/O pattern across all the nodes? Or do you want to leave that to Amazon, where that's their core competency? So I think in all aspects of kind of the early days, want to be thoughtful about how you're spending developer time and resources, and are you really doing things that move the needle forward for your application, for your business, for your startup? And this is a really strange analogy, but I'm going with it anyway. So this is a quote from Seneca, a great philosopher, and he says, "Plodding oxen are much more suited to carrying heavy loads than thoroughbred horses. Whoever hampers the fleetness of such highborn creatures with a heavy pack?" And analogy's flawed. I don't want to be accused of comparing developers to horses. But the point being that let AWS do the heavy lifting, or a cloud provider, let them do the heavy lifting. And you really want to focus on what people who are the best in the world at building applications and things for users. Let them focus on that. One quote in this vein that I find interesting was Mike Krieger, the Instagram co-founder, had a tech talk where he said, your users around the world don't care that you wrote your own database. And I think it's a great quote, because it captures this point about focusing on the customer, focusing on your core innovation, and getting rid of everything else that's a distraction around that. And I think one of the things that I do observe sometimes in a venture role is you do see a syndrome where you talk to a startup, and a lot of times using whatever technology is trending the most on Hacker News. And I love Hacker News. I love new technologies. But sometimes there's a proven tool for a job. And there's a lot to be said for simplicity less moving parts, and using the tool that you know can effectively solve the problem versus being the pioneer that gets the arrows. So that is a point there. Now I'll tell you a little bit about as you scale. So talked a little bit about the beginnings. Where do I want to start? How do I want to think about spending my time and money? Now let's say that you've got a hit on your hands. The dogs are eating the dog food, or they're drinking your champagne, whatever you want to say. And you're thinking about, you're looking at your AWS bill, and you're noticing it's growing right along with, or hopefully not ahead of, too far ahead of your user growth. And you're thinking, well, this is going to get to be a pretty big number. How should I think about managing my costs on my infrastructure as I scale? And I think one of the key parts there is going to be reusing reserved instances and making sure you're really getting the lowest price on the AWS platform in terms of the pricing options that they offer with S3 and with EC2, reserved instances, and Spot. And I think you'll get a great perspective on that from both Flipboard and Yelp, who heavily use reserved instances. So let them talk about that. The other point is having someone that's actually thinking about the costs. And I don't mean this part-time CFO that is looking at the line items and asking incredibly high-level questions like, do we need this? Do we need to spend this much? I mean people that are familiar with the texture of the architecture, familiar with the texture of your overall IT deployment. They can have insightful things to say around overall resource utilization and provisioning. And so Flipboard has an interesting concept there called the chief miser. And I'll let Greg talk about that, but I think that's a key point. Next point is, do you have a model? And so it's funny because in the business that I'm in, you'll see startups come in all the time, and they have their last deck at the end, which is the financial projection slide. And you know, those are always really funny to me because people have their best straight faces on, and they're like, you know, pointing out like what it's going to look like at 2017, 2018, and the product hasn't launched yet, and no one's used it. It's like the only thing I can guarantee is those are going to be completely wrong. And you know, even when you're doing annual planning at a place like Amazon or a large organization where you have a new model, you have a new business, you have a new application, it's really hard to guess where everything is going to go. And so when I say having a model, I don't mean having, you know, being a wizard around exactly where your costs are going to come in at. I mean a model in terms of understanding the relationships between the inputs and the outputs in your business. So when you think about your business and you think about serving a free customer if you're a gaming company, or if you're providing a developer services, if you're thinking about the amount you're going to charge developers relative to the AWS services you're consuming to provide that service, really understanding the input-output relationships there and how those change at various levels of scale. What does it cost me right now to serve a free user in my game? What does it cost me per user, active user, per month, per day, per year to serve that user? What assumptions does that require then for premium or paid users to offset the infrastructure costs of serving those free users? And how is that going to change at various levels of scale? There may be certain things you're provisioning now that look a little bit like while they're OpEx, look a little bit like a fixed cost. That you can amortize over more and more users as you scale. There may be other things that are disjoint in your cost curve where all of a sudden you reach a scale where you're spending a lot of money for them and you want to know what the impact's going to be. So I would say definitely have a model around that and understand the implications for your architecture on AWS. Watch your metrics. So here you're just going to say a little bit about asking yourself the right questions regularly, what questions you might want to ask yourself or your board or your advisors might ask you to make sure you're thinking strategically about your infrastructure and your spend. So I think really identify the key metrics that matter for your business. So I gave the example of a gaming company. So if you're serving a bunch of active gamers every day, month, year, you really want to understand a key metric for you might be what is the dollar in infrastructure spend per month per average free user? What is the variance of that from your heavily engaged users to your less engaged users? What about for premium users? Whatever those core metrics are for the business, really important to stay on top of those. And from an infrastructure perspective, as you're thinking about your AWS costs, I think it's really helpful to have a simplifying metric that takes that AWS bill and relates it back to whatever is the core business metric for you. So if you're a consumer application, that might be monthly active users, and you want to understand what's the cost to serve a monthly active user. If you're a developer service, it might be a different metric around an active developer. If you're providing a SaaS service to enterprises, it might be a different metric. But really having some simplifying metrics that you can reduce your costs down to and track over time can be very helpful. Another good question to ask yourself is, what will this scale to? So I thought it was interesting in Alyssa's keynote this morning talking about the various stages of S3. One of the points she made was, well, here's what our architecture looked like, and we knew this would scale to, I believe it was 20 billion objects. And then we knew we got 3 billion pretty quickly, and then we needed to think about a new architecture that would take us the rest of the way. What's interesting about that is they knew in advance that they could get to about 20 billion users, and they had kind of a framework in their mind around when it started to make sense to re-architect. And I think that's a good question to ask yourself with your current architecture is, about what level of users will this scale to? And then what type of changes would I need to make? And then how far do I think that will get me? So just having a good handle on your cost metrics and having a good handle on where your architecture can take you. Going the wrong way. So the last point I want to make is about startups at scale, quote unquote. And so I think one of the things I observe a lot in my role is companies will say, hey, we think we're reaching a scale on AWS where we're thinking it might make sense to move things in-house. Definitely get that from time to time. And I'm not going to make any bold headline statements around this because every company is different. You're different in terms of your stage of scale, different in terms of the capabilities that you have in-house, different in terms of the stability of your workload and the workload pattern. So far be it for me to make a generalizable statement that applies to everyone. But I have noticed when companies will come to me, I'll often ask to take a look at the analysis they've done that makes them think it's going to be cheaper to bring it in-house. And I have started to see some patterns around some of the systematic errors or biases that creep into that data, into that analysis. And I thought it might be helpful to share with this audience. So one of the most common mistakes I'll see when people are doing this analysis is they're not using the right pricing comparables within an AWS environment. So AWS provides reserved instances, spot instances, and various types of reserved instances as well. And so you can get up to a 70% savings relative to the on-demand prices on the website with reserved instances. And so if you're comparing the on-demand prices versus the cost of going out and buying hardware divided by 36 months, that's not a fair comparison in terms of the pricing that you're using. Another thing where you'll see apples and oranges is utilization. So I think Forrester did a research study that suggested that 60% of storage that people provision is utilized. Well, in an AWS environment, you're using all of the storage that you're provisioning with something like S3. You're running at 100% utilization. You pay for what you use. So are you being comparable there? Also, sometimes people will be in an early stage with their startup where they're not trying to be super efficient about how they use AWS yet, so they're over-provisioned. But then when they do the analysis, then they're looking at a do-it-myself world where I am perfectly utilized and comparing those in terms of a TCO basis. So that's another area. And then durability. S3 has 11 nines of durability. With AWS, you're often running across multiple availability zones. Is that the same comparable you're using in your own analysis? Maybe it is, but maybe it's not. And then I think a couple other key points I want to hear. One is that you should think about this analysis from a long-term perspective, not a short-term perspective. AWS has released new services and features at a remarkable rate over the past few years and show no signs of slowing down in that. And so you have to ask yourself also, how do I want to participate in the new services and features that will come out? Because you might know you're doing the analysis at this point in time, but what if S3 prices drop by 25%? What if a new data warehousing service comes out tomorrow? How should I think about those if I'm doing it myself? And so I think that's the point that often gets lost in analysis. And lastly, let's take it back to the beginning. Are you really focusing on your precious resources, which are your employees, your engineers, your developers? Are you creating distractions? Are you creating complexity? Are you creating things that aren't going to benefit your users? Your users don't care where your infrastructure runs. They care about new products, new innovations, and I think that's really the point here. Everyone is going to come to their own conclusions here. The AWS TCO calculator is very helpful, and so no religious statements around this, but just be thoughtful about the analysis you do and make sure that you're fairly comparing apples and apples as best as you can. And some people will come to different conclusions. Some of our other panelists run both in AWS and on-premise. That makes sense for them, but at least be thoughtful about the analysis you're doing. All right. With that, I'm going to turn it over to Greg from Flipboard, who's going to talk about some of the optimizations and real-world examples from their experiences.
There we go. Hi, everyone. Thank you, Ray. My name is Greg Scallon. I'm one of the engineers over at Flipboard, and I wear many hats, as many of us do in a startup. I do software development, do a lot of architecture, but one of those hats I have to wear is looking out at our AWS usage. I spend a lot of time evaluating what the right components are to use within AWS for our various services, as well as optimizing the efficiency of those resources and keeping the cost down as much as possible. A lot of what Ray talked about are the questions, honestly, that we ask ourselves all the time. We asked a lot of them in the beginning, but you have to keep revisiting those kinds of questions as you're marching along, because some of the assumptions or decisions you made earlier on may not have the same answers as you thought they would as your company evolves. For those who are not familiar with Flipboard, our service is kind of like a web app. We're basically a social magazine where you can flip through different content that's shared with you in your social networks. And so we do a lot of taking content that you find on the web that's shared by your friends and presenting it to you in this kind of magazine-like fashion. So it's not very different from a standard website in that sense. One of the first things that you have to do as a startup is decide, am I going in the cloud or am I not going in the cloud? And the only recommendation I could say there is know your requirements. What I'm going to talk about in this presentation is a specific example of Flipboard, so not some of the generalities of what anyone needs to do, just what did Flipboard go through when we had to make a lot of these decisions. Our requirements were real fluffy. We were building a product that we thought people would want to use in order to browse the web better than a web browser would do today. So we didn't know what that would run on, we didn't know what it would look like, we didn't know what the back-end services would be. The only thing we knew was we had to ship it in 3 to 6 months, production quality, and the user interface team was going to be changing that stuff pretty much up to the last minute. And we had to assume that we would be successful, so you have to design it so that you can scale up very quickly, assuming you are successful. So we looked at what other people done. We looked at what Facebook did. Those guys, they kind of build their own data centers. They even designed 480-volt power supplies in order to reduce their energy efficiency. Other companies like Netflix have moved out of their data centers, gone into the cloud in order to remove all the time they spent doing some of that heavy lifting on infrastructure to focus on the core competency. We decided to go fully into the cloud for our service for several reasons. The primary one was being able to be very quickly, being able to deploy quickly as a service when we weren't quite sure what the feature set would be. And at the same time, being able to scale up quickly. Once we knew what kind of a product we would have, we then would reevaluate whether we wanted to stay in the cloud, whether it was cost efficient to do that, and move on from there. So my first recommendation is when you're thinking about costs is if you're going to go in the cloud and you make that decision, embrace the cloud architecture. It's very different from building your own data center. You have massive resources at your disposal. You can deploy them willy-nilly. You need to make use of that, because if you don't, what you're going to find is that you're hiring people and spending time doing things that you don't need to do because it's the way you used to do things. It could be anything from setting up access control lists on IP addresses, which really don't make sense in that world. At the same time, you should be really afraid of the cloud. I've seen many cases where we've given engineers the power to deploy these things, and they decide they just want bigger boxes. And then they kind of forget about them as they go away over the weekend. So you're eating up money by these things sitting around there because they have this power right from the get-go. And the tools may or may not be good enough for the way you operate. And that kind of goes into, well, when you're working in the cloud, we found that a lot more of the engineers become operations people. They really do need to understand what are all these items that they can pick and choose from in infrastructure and how could they use them, because they don't have to go through a curation process to decide, okay, I want to buy this, give it to me in 3 months, and I'm stuck with this. They can decide, I want to try this today. I didn't like that. I'm going to try something else tomorrow. So we kind of have this DevOps type scenario where every developer is kind of an operations person, and they follow through all the way to release all their products. This kind of evolved the need for what we call our chief miser, which is basically the role of a person who's responsible for making sure that the resources that you are going to go live with make sense for your service, as well as using it efficiently. Just real quick, just to give you an idea for the numbers that we're talking about at Flipboard, We launched in January of we started the company in January 2010, and we launched in July, 6 months later. Over those 6 months, our development costs in Amazon was about $25,000 over those 6 months. That may seem like a lot, or it might seem like little, not quite sure, but that was basically 2 people at the beginning, 20 people after 6 months, the total cost for developing the product before we launched. Once we launched, we needed several hundred instances in order to handle several 100,000 people that came on board in those first few days. At the peak, since then, since we've been around a little over 2 years, we've been up to around 1,500 instances. And right now we're hovering, to be honest, it's about 900 instances, a little under 1,000. When I look at, well, what are our costs? If you look at, we care about daily active user. You have to find a metric that matters for you, for your product. And for us, it's about who is the person who comes back every day reading these magazines, and are they getting a really good experience? Are they spending time in there sharing what they're doing with the people they care about? So we care about, our cost is, how much does it cost to support those people? The cost per daily active user today is 7 times less than what it was when several months after we started out a couple of years ago. At the same time, we've increased our usage quite a bit. Over the last 9 months alone, we've gone up by about 5x in terms of our users and usage, and that continues to go up. So our costs are going down as our users are going up in terms of cost per user. That's because of some of these optimizations that I'll talk about that we've done. First, some general AWS tips. You see these all over the web. You probably, if you're in there now, you're probably employing a bunch of these. But they were important for us. These are the things that we did early on. First thing was if you have to go in multiple regions, either because of availability or because you need to have instances closer to your users over in a different part of the world, keep your intra-region data transfer down to a minimum. You really don't want to be transferring a lot of data back there. A lot of people find issues or that problematic when dealing with databases, but it really is important to think that through before you venture down that path. Another big one that we found is many of the instances we use have 1.7 terabytes of ephemeral disks on them, yet we were using EBS volumes for no good reason, and we were doing a lot of transactions on these things. And we really didn't need to have EBS-backed instances there. We have a very fluid deployment strategy where you can deploy and terminate instances at any time and still be functioning okay. So if you can, leverage those ephemeral disks. They can really save you a lot of money by keeping everything on the local disk. Another key point was expanding EBS volumes as needed. When you have a lot of EBS volumes, you don't want to deploy too much in size and then not use it. They do cost money. Spot instances, you're probably familiar with them. They're great for batch jobs. Use them wherever you can. Jim's going to talk more about that. Kind of hard to wedge them into your instances when they can't just magically go away, but there are some things there. But I have seen them 10 times cheaper than on-demand instances, so that is something to keep in mind if you can leverage those. Avoiding elastic IPs. I've had developers who've built their code knowing that there's an elastic IP fronting a service, not realizing that those go over the public address space and you're getting dinged for all the data transfer going over that. So we've kind of avoided those in general and proxied everything through the private address space and hidden that and only open up elastic IPs in the few cases where you have top-level domains that have to be public-facing, and then we never write to those internally. The last thing I'll mention is rolling upgrades. Everyone does them differently, but they can be very costly depending on how you implement that. Netflix, for instance, I saw a great presentation yesterday where they talk about how they will deploy a whole pool of machines when they want to do an upgrade in parallel to their existing pool, and then they'll solely migrate users over for a given day. It's a great way to be able to make sure that you can roll back quickly. If you have any issues, you can look at the data independently, but you're also going to have twice as many resources out there at the same time. If you don't have a large company where you can kind of leverage that other groups aren't using those instances and you can migrate those machines back and forth between the different groups, that can be a costly proposition. So you might have to look at doing rolling upgrades, for instance, amongst your machines instead and organizing them in groups. So what does this chief miser do? How do we optimize stuff? Well, sometimes you have to make decisions where you're not going to optimize your cost. You're actually going to spend more money. So for instance, cost versus performance or cost versus availability. I don't want to go into too much detail here, but in many cases we've made decisions where, for instance, we have had to deploy more stuff, going from deploying static assets out of S3 into a CDN, and also into another CDN in order to have the performance be fast when coming from mainland China, for instance, because, for instance, CloudFront doesn't have an edge location within there. So you do have to make those decisions, and they will matter. You have to go back to, are your users happy, and looking at the data there. Same thing with availability. We tend to go with RDS with higher database instances because every once in a while, since our developers, we're going really fast, we're throwing a lot of queries out there, we may not catch all the queries in certain situations where they will kind of spike and add burdens to your RDS instances. So in our particular case, we'll go and deploy this code, and it may bring the RDS instance to a screeching halt. So instead, we deploy a bigger one, and we put thresholds at a much lower level so that if something does happen, we can kind of catch it and get those changes out there to resolve it. Again, that's in the case where we didn't save money, but we actually, were spending more money. So day to day, the most important thing I'll say is data. Look at all your data. Look at what's coming in from your machines. We stuff everything in something called Graphite for visual. We stuff all of our logs into a Hadoop cluster and run Hive and reports on these things. That data kind of tells you how your services that you're building, how efficient they are, and how you can go about making them more efficient. One of the first things we did is we had a model of you can deploy and terminate any instance anywhere, anytime. We can deploy an instance of any role within about 2 to 10 minutes, depending upon the instance type. And we do that by making sure that when you hit that deploy, there's nothing we fetch over the public internet. Everything is prepackaged into the AMI, and there's only a little bit of code that goes on and gets configured when you deploy it, and there is no state in those boxes. Everything is stored elsewhere. One of the benefits of that is that you can now use auto-scaling very well throughout your whole project and scale up and down your machines on demand, and I highly recommend that. It is a very important area to focus on. And nuke snapshots and unused resources. Just check those things and do it whenever you can. I'm not going to talk much about RI use, but it's huge for us. When you can get a certain roll of machines or set of them to have non-spiky behavior, but nice steady state, they evenly use their CPU and memory resources, and you're not changing that code too much, it's a great time to look at buying a 1 or 3 year investment in the machines that are going to use that rather than paying on-demand prices. We do on-demand when we tend to have spiky, unknown behavior and still changing stuff, but then we'll go to the 3 year. We found that the overall savings over 3 years would be about 80% when you buy the heavy-duty ones, but the break-even point's only about 8 or 9 months out there, so that if, for instance, you decide to leave the cloud after in 9 or 10 months, you're not losing money, even though you paid that 3 year up front and you're not using those resources. And again, look at your bills. It's a really important point there. Finally, I want to give 4 examples of things that we've actually done that have reduced those costs, that were some of the bigger reasons for this. When we first deployed the service, we needed to get out there very quickly, and we made a decision that we were going to go out in a language that we felt we could implement changes to the back-end service very quickly as our user interface designers were changing the product on us. And the language we chose at the time was Ruby because it was great for that. There was so many free libraries out there that you could pull in or that we could pull in to quickly get versions of the software out there. It was great for prototyping, and it worked in our first version of our production service. However, we found it very costly. There's a number of ways that we could have gone about optimizing it, sticking with that language and doing other things, but we decided for a variety of reasons just to convert it over to Java and try to get more efficiencies there. And so just focusing on the language and how you use it and how you make it efficient was one way that we were able to save a lot of money. We reduced the number of instances we needed by 5x on that alone on both the front-end and back-end systems. SSL decryption, we had a bank of Apache servers doing that. We switched it over to an elastic load balancer, saved us about 20 instances right there from the get-go. And the ELB costs were just very minor relative to that. It was very static. Another thing I'll mention, everyone may not know this, but compressing all your data in and out of S3 if you can, or compressing it in and out of your service over the public network will make things a lot faster, especially if you have an app running on 3G networks or 2G networks over in China, as well as reduce your costs because there's less data going in and out of the public address space of Amazon. So that's something else that we do very often. Image processing versus content processing. So we process a lot of content, articles, images, sound, things like that. Image processing can be very spiky. Face detection algorithms, stuff like that. You get a big image of 20 people in it, it's going to take a lot of time to do that. You get a gallery of 200 images doing that, you're going to start spiking all your machines. When we put that on the same as our content processors, then all those machines would kind of spike, and we weren't really getting very good efficiency. So what we did is we separated all of our roles of machines into those that are kind of spiky and those that aren't. And when they aren't, you put them off separately, and we get very nice linear, we can run them all at 75% CPU and never worry about them having problems. They'll scale up and down nicely. The image processing ones, you need a little more breathing room, and so we would put anything with spiky behavior off separately. And the last thing I'll mention is caching. You have to utilize many layers for that so that you're not exerting time and energy on CPU and other machines. So I hope these kind of tidbits help and enlighten people on some of the things that we've done over at Flipboard. They really have made a big difference in terms of the number of machines that we've needed to build the service. So at this point, I'll hand the mic over to Jim. Thanks.
Thank you. All right. Thanks, Greg and Ray. My name is Jim Blomo. I work for Yelp on one of the data mining teams. I also teach data mining and a web architecture class at UC Berkeley. And I wanted to talk to you guys about some of the things we do to save a little bit of money. So as background, Yelp does host the website in our own data centers, and we use EMR primarily and S3 in order to do offline batch processing. That works pretty well for us. Like Ray was saying, you really have to kind of figure out what your own needs are in terms of hosting fully in the cloud versus in your own data center. We started out pretty early, and so went with the data center. And I don't think, in my personal opinion, I think once you're in one area or the other, it doesn't make a lot of sense to try to move back and forth. I think you got to stick with what works for you and make the most of it. So let's talk about how we make the most of some of our tools. As a little bit of background on what we use EMR for, I'm going to give one example here, the review highlights. So some of you may have seen this on Yelp. We have many businesses that have 1,000 or more reviews, and we don't expect you guys to take the week off and read this book's worth of reviews in order to figure out where to go to dinner. So we try to extract the useful phrases from these reviews, the ones that are common to that business but not seen elsewhere. And we do that in the EMR job that takes data from our databases, uploads it into S3, and then uses EMR and Hadoop to process those. And Yelp has a pretty wide variety of data. So we do this sort of thing with log data, with database data, and kind of combining that together. This is actually one of my favorite bars in San Francisco. One of the top phrases there is tamale lady, and that's not a mistake. The tamale lady is real, and she comes to this bar, and you can buy some tamales if you're ever in San Francisco and want to go to Zeitgeist. So our AWS usage in specific, so this is a graph of M1 larges that we use. M1 larges are like our workhorse machines that we most often use. These graphs are all generated by an open source program called eMario that I'm going to talk about a little bit in more detail. But in general, what we want to see here is it's pretty spiky, right? We have peaks of over 350 instances across our different use cases, and troughs down to 0, typically in the holidays, that sort of thing. And the charts will talk about the colors a little bit more, but let's look at the cause of these peaks. So we're based in San Francisco, and so all of our developers are there. Almost all of our developers are there in San Francisco, and they come in at 10 a.m., or let's be honest, 11 a.m., and they spin up all of their jobs that they're working on kind of in that same time frame. So in the development area, we have spiky load already because people are working on their work at the same periods of time. In the production world, it's pretty similar, except it happens at 12 a.m., when we upload all of our logs, and we need to go through and calculate things like click-through rates, advertising revenue, look at user behavior data to generate new user models for the next day. And a lot of times, we want those to finish as quickly as possible so we can use that data as quickly as possible. And when that happens, we see large spikes of usage. And finally, there's like this vicious cycle that, vicious and maybe for billing, although I'm sure Amazon is very happy. But once you have this mindset that if you have, that you're going to be billed the same way for 1 hour of 100 machines or 100 machines over 1 hour, right? The developer is not going to want to wait 100 hours, so they spin up a cluster of 100 machines, which is great for developer productivity, and it's that trade-off that we explicitly wanted to make to enable developers to move quickly, but it generates even more spikiness here. This is an image of one of our C1 extra larges, and you can see there's kind of some thick bands there of spikiness where we were trying to backfill a new feature, and we wanted to use a whole bunch of large machines for a longer period of time. So like I was saying, we've kind of chosen the developer as the primary thing we want to optimize. And there are many trade-offs you can make and try to alleviate costs in different ways. But we've told developers explicitly, move quickly, try to get new features out there. And when you're ready to deploy it. And run the jobs when it's best for the situation. So run the jobs right after the logs are updated, and don't spend too much time trying to like coordinate with other teams about when we should be using resources. The trade-off is pricing. So this spikiness means you can use fewer features in order to keep your costs down. But I encourage all of you guys to think about, what is the bottleneck in your business? Is it really that 10% you're going to save by telling developers to kind of smooth out stuff? Or is it getting the features you need to get the users you need to get the revenue you need? You know, are you being penny wise and pound foolish? So let's talk about some specifics here. Just for reference, who's familiar with EMR pricing and how it works? Not very many people. So, no one's familiar. Okay, well, I guess that's why you're here then. So the way EMR pricing works in general is you're paying by machine hour, and that hour is rounded up to the nearest hour, right? So if you run a typical EMR job flow like this, you run a job and then you shut down that cluster and you're done. Now, if that job lasts just slightly over 2 hours, you're still paying for the extra amount of time that goes to 3 hours, but you're not using it, right? Your job is done, that pool is not used anymore. And so what we've done with some software I'll talk about in a minute is this concept of job flow pooling. So in the last slide we shut down the job flow when the job was done. Now instead what we're going to do is keep that job flow running. And if another job comes along and wants to use a similar sized cluster, then we notice, hey, this job flow is free, let's go ahead and use it. And that reduces the overall waste that you're using because you share those resources and you kind of can fit stuff in the idle machines that you've kind of already paid for. And you can see how over time with many job flows this can work out well. And one of the details down here is if you're willing to wait a little while for new jobs, you can wait maybe 20 or 30 minutes to see if an idle job flow kind of shows up, and then you could use that instead. We mostly use that feature for production jobs because no one's kind of waiting around for a production job to finish, and 20 or 30 minutes usually doesn't matter that much. One of the benefits of this is, again, in that focus on developers, is it actually typically makes the developer's life easier. Because if there's a free job flow, now they're waiting seconds for their job to start up and work instead of minutes, 5 to 10 minute range. And it also makes people a little less nervous about trying out their jobs on new data because if you end up using EMR, one of the problems that you'll run into is you're all excited about your new job, and it's like ready to go, and you put it up, and in the first like 5 minutes, it completely crashes because some unexpected data input has completely crashed your program. And in a normal sense, you might shut down that job flow and have to start all over. So you just bought an hour of machine time that you didn't really use. So job flow pooling helps that case as well. Now let's go on to a different billing topic, reserved instances. So we talked about how you're billed per machine hour. Now those per machine hour costs can go down if you buy an upfront promise to use that machine a certain amount. So reserved instances, the value proposition there is you pay more money upfront, and then you pay less money per hour. And the amount of money you pay upfront is determined by this class of usage, this light, medium, and heavy. So you can use these in order to reduce your total costs in exchange for some extra capital expenses. And one of the important things about reserved instances is they're a billing artifact, okay? You're not, picking out your favorite machine in the data center and saying, I want that one for a year, and you'll always get that machine. What happens at the end of the month is Amazon looks at your billing and says, oh, you actually have these many reserved instances, and this is how many you actually use, so I'll apply these pricings here. So it's a billing artifact. And there's some complexities we'll talk about if we have time. But this is the general idea here. And one of the things is, using these can really depend on, let's see if I can get my mouse over here. Using these can really depend on how much you use a machine. So the more hours on the x-axis, the more hours you use, the different amount you'll want to pay up front in order to get that total cost benefit. So how do you figure out what the right cost is? We have an open source library called eMario. You could check it out on our GitHub page. Sorry, that's a little cut off. github.com/yelp/eMario. It stands for EMR Instance Optimizer, but you could think of Mario if you want. I always do. So what it does is it takes this data about how much these reserved instances cost. It uses the EMR API to see how much did you use in the last couple months. And it says, OK, in a perfect world, if you had this many reserved instances at these different levels, then your bill would have gone down by X thousand amount of dollars. And you can use that recommendation to go ahead and purchase reserved instances for future use. And this example is useful. These are M1 smalls. So we actually use M1 smalls as the master node in our EMRs, because the master node is not doing that much. It's not doing real processing. So you can keep a little bit of your cost down by using an M1 small instead. But it really highlights these different levels. At the bottom, we have a light blue. That is the amount of high usage reserved instances. And we want high usage there because we always have one of these M1 smalls running somewhere. Because if we have any cluster up at all, we have an M1 small running. So having a high usage reserved instance there helps you save those costs. Now, as someone in another session pointed out, it isn't all unicorns and rainbows. There are some gotchas to using this type of stuff. You are reserving machine. You're not reserving a specific machine, but you're reserving a machine in a specific region. So you need to make sure all your configs are correctly using that region where you bought those reserved instances. You don't want to buy a bunch of reserved instances in one region and start doing your work in another. You're not going to see those cost savings. So balancing out those regions and buying things in different regions is one of the future areas we want to look at for EMR, but it's one thing to be aware of. And again, there's many more pricing details for reserved instances, so take a look, make sure you understand it. There's now a marketplace where you could buy other people's reserved instances, and it gets a little tricky. But in general, it can be worth it, and with eMario, it's a lot easier. Make sure you know what your desired instances are. This is that traditional trade-off between capital expense, buying stuff up front. So we did, before we kind of went full hog on this, we ran our different typical jobs with completely different composition of machines. So we tried out things on a C2 extra large or whatever, and then we tried it out on all M1 smalls, and we figured out what was the most optimal before we kind of made a year-long commitment. And in that same area is then standardize your cluster types. Job flow pooling works because you can use the same type of job of cluster over and over. So if you have standard jobs, job flow configurations, and we have 3. We have the M1 larges, we have C1 extra larges for CPU intensive stuff, and then M1 extra larges, I believe, for the memory intensive stuff with some extra options to turn on swap and that sort of thing. So standardize on those cluster types so you can make sure to reuse those clusters really easily. And reusing those clusters is a built-in, the job flow reusage is a built-in feature of our other open source project called MRJob, which I discussed in another panel. But what it does in general is allow you to write Python for your MapReduce jobs, but it also spins up these EMR clusters for you. And to kind of close here, keep in mind these things aren't free. We did have a really keen eye for how much developer time we spent developing these tools. And the 10% line is, that's starting to get borderline of how useful it is to have a developer spend a lot of time on this. Now, developers in general were impacted, but there were bugs in this. The job flow pooling, we accidentally let some jobs run too long. EMR itself had a bug for a while where job flow pools were in a weird state where you didn't realize they were idle and therefore didn't kill them. So it's not free. Developing this stuff is not free. So really consider how much you're likely to be saving. And like we talked about, spot instances, I think, are the next area we're going to really investigate. We actually looked at them a year ago, and it didn't look like the savings was that great. But nowadays, you might be able to get really significant savings by using spot instances. And I can't walk off stage without mentioning that we're hiring, because we really need people to continue making these open source tools, using big data in innovative ways. And if you can imagine a position at Yelp, we're probably hiring for it. So with that, I'll turn it back to Ray or see if we have time for any questions. I think we may have no, we don't. Empathetic head shake. So we'll be outside if you guys have any questions. Thanks.